that stores some data that can be used later on. So for example, this X is a symbol, character or a symbol, Y is a symbol, X, Y is a symbol. Normally, and these are called names of the variables. For example, this is a variable name X, Y is a variable name Y, X, Y is a variable name itself. Now, these variables, they can store different kind of data. I mean, whenever you want a particular data to be used again and again, it is better to save that data or label that data by a symbol, by a descriptive name, so that you can retrieve that name, retrieve that data by using that label or symbol. So one way or the other, this variable actually is a description of the data that you want to use or store and you want to use later on in your program. Different types of data are there. For example, the integer type data. For example, if the data you want to store is integer type, it's a number, and the number is just the integer number. It does not have a decimal point expansion. That is a type of data, and that can be stored in a variable. In that case, the variable type itself will be integer. You need not to specify the type of variable when you are storing the data to it. Storing data to a variable is sometimes called assigning data to a variable or assignment. For example, if your variable is X and you are assigning a value, let's say 2, then 2 is integer value. It's integer, it does not have a decimal expansion. And when 2 is assigned to X, based on the content 2, that 2 basically is an integer type value, automatically the type of X is set to be integer. And that is sometimes called the dynamically typed, Python is dynamically typed language or dynamic typing. You need not to specify the type of the variable. The contents that you are assigning to a variable, they will define the type of the variable on the fly. And the assignment, for example, in here I am storing 2 inside X, and next time if I want to print, for example, what is there in X, the print value will be 2. Now, this kind of symbol is hard to write. There is no keyboard symbol that looks like so. So rather than writing this symbol for assignment, normally an equal sign symbol is used for assignment. For example, X is equal to 2, that means 2 is assigned in X. Y is equal to 5 means 5 is assigned in Y. 7.2 equal XY equals 7.2. XY is completely a new variable. It has nothing to do with X or Y. And it is handy sometimes to suggest the name of the variables that are too descriptive, that are very, very descriptive, to increase the readability and management of the code. Because later on you'll be seeing, when you will be working in data science and other stuff, the programs that you will be writing might not be very short programs, they might be lengthy programs. So readability of a program and management of a program becomes an issue if you do not assign the names of the variables carefully. However, if you write the names in a very descriptive way, by just reading the name of the variable, by just reading the variable symbol or the name, it tells a better look and feel of what kind of data inside and what should I do with that. So I was talking about this equal sign. This equal sign is used for assignment. Here, for example, when 7.2 is assigned to a variable xy, automatically the type of xy variable is set to be a floating point number. A float is a data type in Python that describes that the particular data is a real valued. It may have a decimal expansion as well. Not just integer and floats are the only data types in Python. There are several others. For example, you can define complex numbers if you want to. You can, for example, defining a complex number might be, for example, you write the name of C and you write 2 plus 4j. If you write the symbol j here, it automatically becomes complex. And now you can use this C the way the complex numbers should be treated. Similarly, there are other data types like fractions, decimals, There are further data types, the objects called strings. For example, if you assign, let's say, s equals double quotes hello, then that s is also a variable, and the type of this variable is string. String is just a sequence of a lot of characters, where H is a character, E is a character, L is a character, L is a character, O is a character, W is a character. And when we will define anything, any sequence of characters inside the double quotes and then end the double quotes here, or the single quotes and double quotes, either way, then the type of this S becomes strings, and these characters should be treated as it is. Like for example, if we have another variable s2 and we just say 1, 2 in double quotes, now this s2 is no longer 12 as an integer. It is a sequence of characters where first character is 1, another character is 2. We will talk about strings in detail in the upcoming videos, but just to give you a look and feel that Python actually supports a lot of data types, a lot of interesting data types, including the most important data type is integer, float, and string as well, that we will see in detail. Further, you can assign more than one values to more than one variables in a single line. That is sometimes called multiple assignment. For example, if you write a comma b equals 4 comma 5.0, then 4 will be assigned to a and 5.0 will be assigned to b. Notice one thing, although 5.0 looks like an integer, but when you write a decimal expansion, it automatically becomes float. So if you now type if you now check the type of a, it will be integer, and if you check the type of b, it will be float. Once you have declared a lot of variables, they stay in the memory, they occupy a particular space inside the memory. For example, x is just a label to a memory. Inside the memory there is 2 located somewhere. Similarly, y is also located somewhere in memory, and similarly xy is also located somewhere in memory, and this is the data inside that memory. These will stay in the memory and they occupy the memory. If you decide to no longer use a particular variable in future in the program, then you can call this function del space whatever the variable name, and it will delete the variable from the memory like it was never there. And once the variable is no longer in memory, it is not accessible. If you now access the variable again, you will get an error. Let's see all these concepts. Let's see most of these concepts in Jupyter Notebook, and let's actually define certain variables, use them, print them, do some multiple assignment, and see a lot of stuff in Jupyter Notebook. So let's go to Jupyter Notebook. So that was our notebook that we were actually working on the last time. So let's say I define a variable x. Let's say x is 2. Why not I should describe this as what we are doing here is, let's say, variables. So just to give a heading that we are now in variables. So variables, notice that now I'm in a code cell. Previously I was in a markdown cell. Notice this change. In this particular cell, this is markdown. In this particular cell, this is code cell. See that, code cell. Okay, x is equal to, let's say, 3. Let's enter this. Now x is assigned a value 3. If you want to know how many variables right now are there in the memory, we can write this command whos. This is a percentage symbol. If you write percentage symbol and then just type a command whos, it will tell you all the variables that are right now that are there in the memory. And right now the memory has a variable with name x, its type is integer, and the data inside the variable is 3. That's the memory view that you are now seeing. Okay, if you want to explicitly check the type of x, you can print type x. So for example, this function type will actually finds out the type of whatever variable you give inside, and then this print function will help you printing that on the notebook. So if you see the type of X, the type is basically its integer type. Now if you, for example, change the value of X as 3 to, let's say, 5.7, so you have same variable, but you just change the value from 3 to 5.7. So let's see what happens now. So if we call whos again, we have now the variable name is still X, but its type automatically changed to floating point number because we assign a floating point number to it, and this is the data. If we want to explicitly check the type of this X, that would be class float now. Further, let's say we have another variable A, B, C, D, that's a variable name, let's say, and we assign a value 556.32, that's a value. If we now call the whos function, whos command, we will be having two particular values. One variable as ABCD, its type is float. Another variable is X, its type is float, and that is there. If we, for example, do a multiple assignment, for example, A, comma, when you write comma, first variable finishes, second variable starts. A, B, C, D, F, let's say, these are 5 variables. And if you assign 5 values to 5 variables, again in a comma separated list, 3, 5, 6.0, 7.2, and let's say -3. So if you enter that and you now check the status of the memory, because now all these values are assigned to their respective variables. If you now check the memory view, A is an integer type variable with value 3. ABCD, the old variable that we assigned earlier, it's already float. B is also integer, it has value 5. C is float. C is float, although 6.0 looks much like integer, but when you write a point explicitly, it becomes a floating point number. So D is again float with 7.2. F is integer, it's -5, and X is the old variable that we know already. Now, if we, for example, delete a particular variable, if we, for example, we no longer want to use ABCD variable, ABCD, that's one variable that we don't want to use in future. And now if we see again the view of the memory, we don't have this. And if we now want to access this, for example, if we want to print this, A, B, C, D, we will get an error. We will get an error, and we should get an error because this particular variable does not exist in the memory. It points to no data. It is gone. It is gone like it was never there. So that's about the variables. We just talked about integer and float. There are several other variable types as well. For example, let me just give you an example of a complex number, if you are really interested in. That's a complex number. If you print its type, so that the type is complex. Similarly, you can have a string variable. Let's say, hello, how are you? That's a string variable. If you print type of this, you will get a string. We have a whole set of videos just on string data type because this is very important data type. We will see that in detail. But the purpose here is just to tell you that there are a lot of data types that Python supports, and Python is dynamically typed. Whatever content you are assigning to a variable, that content decides the type of the string. You need not to specify. So I end this video here. In the next video, we will be talking about operators, basically what kind of, so once we have decided, once we have declared, once we have defined a lot of variables, what we can do with these variables. Can we add two variables together and get the result stored in another variable? Can we multiply two variables together? Can we have an operation like addition on mixed types? For example, one variable is a floating point number, another variable is integer type. Can we mix up those? Can we add two different types of variables together and get a result? Then what will be the type of the result, and so on. So a lot of these discussions on operators, the very basic arithmetic operators on these variables, particularly the integer and float variables, we will see that in the next video. So hope to see you in the next video. So in the last video we saw variables, and we particularly saw integer type variable and floating point variable type. We also saw very briefly on Jupyter Notebook, we saw complex and string as well. So in this video we are going to talk about operators, basically the arithmetic operators. Obviously, if you are defining variables, you're not defining the variables just to view them later on. Most probably you'll be storing data to the variables, and then you're applying some computation on a set of variables together, computing new results, saving that, and doing some stuff. Most probably you will be adding two variables, one way or the other inside a program. You may have to add two variables, you may have to subtract a variable from the other, you may have to divide a variable, you may have to compute. For example, these are arithmetic operators. Let me just, this plus symbol is used to add two variables. This minus symbol or subtraction is used to subtract a variable value from the other variable value. Obviously these all are operated on values, not the names. Division, like the name suggests, it's if you want to divide this percentage symbol, when it is applied to different variables, if x is on left and y is on right, what it does, it actually divides x by y and checks what the remainder is. For example, if x is 27 and y is 5, then what's the remainder? What do you think? If we divide 27 by 5, what's the remainder? The remainder will be 2. Yes, so the result will be 2 here. So this computes the remainder. This multiplication, this star symbol is used as multiplication. Like in mathematics, we normally write this cross symbol, but in Python and in most of programming languages, star symbol is used to achieve multiplication. This double slash is like the division, but it is division with the result flowed to the quotient. What I'm saying is the following. For example, if you divide, let's say 10 by 3, the result will be a floating point number, and the result will be 3.33, something like so. But if you want just a quotient, not the remainder, if you want the integer, that's the quotient value, 10, you write the double slash 3, and it will return just the value that is there before the decimal expansion. So this value will be returned. So this is kind of the integer division or floor division. This double star is used to compute the power. For example, if you want to compute 2, you write double star 4. That means 2 raised to the power 4. In mathematics, we write this as following. And the result will be 16. You can save that result in another variable, or you can just print it, or you can write that in a file or whatever. So these are most important operators. One thing that I want to tell you, that these operators are not just for integers and floating point numbers. The applications of these operators is much broader than these. Later we will see the objects or the data types that are collections and the data types that are beyond these integers and floats, and still there, this plus, minus, division, and all, some of these or all of these, they have their meanings there. Even this plus is used for strings. Now think, for example, if you have a string, let's say hello, and you have another string, for example, let's say this is string s1, and you have another string, let's say s2, which is y, then Python allows you even to add these kind of data types. Although some doesn't make any sense, with these kind of string variables, but we will see for different kind of data types, the definition of these operators, they actually change or adapted accordingly. For example, in mathematics, we are much more fluent with plus, with division, with subtraction, and it makes sense to add two integers, to subtract a floating point number from another floating point number and stuff. But with data type that is unfamiliar to you right now, these operators may not make that sense to you, but there are definitions, there are ways to use these variables for the data types that are even beyond than integer and floating point numbers. We will see all these details as we move on to the videos, and I mean, as in later on we will see all these things in detail. But just to tell you that these operators are not just limited to integers and floating point numbers or complex numbers, they can be applied to several different data types. So a lot of words, I guess you are bored now. Let's go to Jupyter Notebook and have fun with these kind of concepts that we are dealing with. So yeah, here. So let's first press escape, then M just to change it to markdown, and then escape 1 for heading, big heading, and here I write, let's say, operators, and shift enter, it runs and automatically then go to code. Okay, now let's say I have a variable. So let's say what kind of variables I already have. In the previous video we used that, so we already have these kind of variables with us. Now let me define a new variable. Let's say sum of a b, that's a new variable. Sum underscore ab, that's a variable name. You can have a better variable name, maybe sum of a and b, that might be a variable name. It is good to have the variable names that are descriptive, that describe what data is inside, because in programs, the programs become manageable, readable, and a lot of benefits are there. So sum of a and b, let's say that's a variable name, and you add a, b, you just write a plus b. Let me make the zoom level a little high so that you can see it clearly. So a plus b, let's say that's there. If you press shift enter and now you print sum of, by the way, if you have written sum of, you need not write everything, just press tab and it will automatically complete the remaining part of the variable, and press shift enter and you have 8. If you check the type of this variable, sum of tab, automatically completes tab, that is called tab completion. Wow. It's integer. The type of this particular variable is integer. That's a new variable. And why the type is integer? Because a was integer, b was integer, and integer plus an integer is an integer. What if we add an integer with a floating point number? What do you think? What should be the result? If I just type a, that's an integer, plus d with some floating point number. So a plus d, the result will be here, and type of that result, what will be the type of that result? What do you think? Let me pause here for a few minutes, and no, not for a few minutes, for a few maybe seconds, maybe 2 or 3 seconds. What will be the result? What will be the type of an integer and a float combined? Well, the types are upcasted, which means the floating point number, the result will be a floating point number, and the reason is every integer by default is a floating point number. Floating point number is an upper class, or you can say a superset. So in Python by default, the types are upcasted to supersets. So here, integer plus a float, the result will be a floating point number, and that's the result. You might be thinking why we haven't stored the result in another variable. Well, if we want to store the result in another variable, we can, or if we just compute the result and apply some operation on that, we can do that. For example, we could do the following. For example, a plus d That's whatever the result is, raised to the power 3, whatever the result is, divided by maybe 4, and we just save that in a new variable. Let's say the new variable is v. Let's say we save that value in v, and now we print v, and we have the result for v. Wow. So we can do a lot of stuff with these kind of variables. Let me show you fancy stuff that we will see later on. Don't worry if you don't get it. Just S1, for example. S1 is hello, and let's say S2 is world, and we have another variable, let's say S, which is S1 plus S2. What it will do is it will just concatenate them together. We will see strings a lot later on, but just to tell you, this plus is not just for numbers. It is for other data types, very fancy data types that are there. One more thing, let's say we define 10 and we divide it by 3, and we want a quotient. The quotient is 3. However, if we have 10 divided by 3, shift enter, the result actually is 3.33 and so on. You might be wondering, we have not saved that result in a particular variable. So where the result is saved? Actually, if you do not save the result, if you do not assign the result, for example, in this way the result will be assigned to a variable r. But if you do not assign, if you do not store the result in a particular variable explicitly, by default there is a variable in Python which is underscore. Underscore contains the last result that you did not store in a particular variable explicitly. So if that underscore is basically one default variable for the result. If you want, don't try to update this underscore. Just read it. Do not assign anything to underscore. For example, if you assign something to underscore, assignment will be done, but then the properties of underscore will no longer be there as they are in Python built-in properties. Okay, so that's about it, I guess. So that was the operators. We will see the operators more and more later on, but before ending this video, I leave you with a question. So the question is, we saw the variable names like sum of a and b, x, y. Variable name can be lengthy, can be descriptive, can be short, anyways. So the question really is, can a variable name start with a digit? For example, is it possible that the variable name really starts from, for example, a digit? Is a 3x valid variable name? Or for example, at the rate of y, is that a variable name? Or for example, this symbol times 2 times x, is that a variable name? What are the conventions for variable names? Can we write anything? In the left hand side we write, let's say 3x is equal to 4. That means 3x is now a variable name. Is that true in Python? Or are there conventions to define the variable names? So yeah, think about it. I'll see you in the next video with the answer to this. So I hope you'll be having answer for this question. Hope to see you in the next video. Okay, so in the last video I asked you a question about the naming convention of variable names. In particular, I asked you whether 3x is a proper variable name or not in Python. So what's your answer? Yeah, what do you think? How many of you say no? How many of you say yes? Well, by the way, you might have tried that, declaring that variable name in Jupyter Notebook, and then you might have got this answer, one of these. Well, let me tell you, the answer is no. A variable cannot start with a digit. not with at the rate of, not with hash symbol, not with, I mean, there are several other, the special characters are not there except a few characters. One of those is underscore. Let's go to Jupyter Notebook and check this. So for example, 3x equals 5, error, invalid syntax. Let's say at the rate of y equals 4, invalid. Star t equals 4, error. Well, an exception is underscore. Underscore e equals 6. That's allowed. Starting a variable name with underscore is allowed. It is different than the underscore that is built in underscore. This is underscore e is different than simply underscore. So it is good to not declare the variable names that start from these because you will be getting errors. Further, variable names should be descriptive. They should give you a look and feel of the data, what they are containing, and you're free to define variable names as descriptive as you want. So it is a good practice to start writing the variable names in a better way. One better notation of defining these variable names, even the function names, we will see the functions later on. One way to defining those is to use camel notation. Camel notation is you start with the variable name with, for example, lowercase letters. Let's say your variable is starting time of the course. Let's say that's your variable name. So you write starting, that's one word, finishes. Then the next word should start from capital T, starting time of the course, let's say. So this kind of notation is called camel notation and very famous, particularly the Java developers. They normally follow this and several other developers. But you should come up with a notation that is one notation. There are other ways of keeping the consistent strategy of defining variables. There are several other ways. This is one way. So starting time of the course is, let's say, 2.0, let's say. So that's a variable name. If you now check, that's a variable name. But now if you see this variable, just the name suggests the data inside is doing what. So the names should be descriptive, I mean, and make that as a habit. So yeah, I guess we have now answered our question very concretely, that a variable name cannot start with a digit, not with any special character other than underscore. Okay, in the next video, I'll be introducing comparisons with variables. For example, what if you want to compare whether one variable is smaller than the other or not? What if you want to compare whether the two variables, they are containing values, they are same or not? What if you want to do comparisons of the data that is stored inside the variables, and based on the result of the comparison you want to do something else? So in the next video we will see a bool data type that is very, very famous, and it is used a lot in decision making. And we will see the comparison operators, sometimes called the relational operators, in the next video. So hope to see you in the next video. Okay, in this video we are going to talk about a data type which is called bool. That's very, very famous data type. Actually, it's the most famous data type because it is used in decision making. All the control flow, most of the control flow depends on this data type. Although it is very, very famous, very much applicable data type, it is very simple. It is a data type with just two states, with just two values. By the way, there are capacities of different data types. For example, in integer, the different kind of values that you can store are huge. You can store any negative number in it, you can store 0, you can store any positive number. The capacity of floating point number, or the number of values that it can save, is even higher than an integer, and the complex number is even higher than that, and so on. But the Bool data type, it has just two states. One state is true. It has just two values. True is a value and false is a value. Just these two states, true or false. In some programming languages, the true is denoted by 1 and the false is denoted by 0. But in Python, the true is just true, true, that thing, and false is false. That's it. If you, for example, define a variable, let's say any variable name, whatever the name is, let's say b, and you assign true, then its default data type will become bool. And if you have another variable, let's say c, which is false, then c is also bool. One thing that is important, there are other operations other than arithmetic operators that we saw, adding, subtraction, division, and stuff. There are other operators that we can apply on Bool data type. For example, a true and is a keyword, combining true and true. If there is a variable, let's say a, if there is a Boolean variable a with data true, if there is a Boolean variable b with data true, then a and b is also true. So let's say I've used this variable d in storing this a and b, the d will also be true. So true and true is always true. Further, true and false, this is always false. And this is commutative. For example, true and true is true, true and false is false, false and true is false, false and false is false. So if you apply AND operator and keyword to combine the two Boolean variables together, if both are true, then AND will result a true. Otherwise, AND will result a false. Other than this AND, there is another operator, keyword OR. So this results false if both are false. False, false. False or false is false. If any one of these is true, then the result is true. Remember the difference between AND and OR. AND will result false if any one of the two operands, at least one of the two operands is false, then the result is false. If both are, or AND will result true if both of the operands are true, otherwise it is false. OR will result false if both of the operands is false, are false, otherwise it is true. So you now know AND, you now know OR. There is another operator called NOT. This is NOT. So NOT, for example, returns not true results false, and not false returns true. Great. So NOT is a unary operator. Unary means it just takes one variable and operate on that. AND is a binary operator, like plus is a binary operator. It takes two variables to operate on. OR is a binary operator. It takes two operators. It takes two variables to operate on, and so on. So remember these things. One, AND will return true if both of the variables are true. Otherwise, the result is false. OR will result false if both are false. Otherwise, it will return true. And not just flips the state. So not true means false, not false means true. So these are basically, that's how you can combine the Boolean variables together. In the next video, we will be seeing how to apply these comparison operators, and the result will be Boolean types, and how can we combine the Boolean types together to build a better decision making. So in this particular video, I just introduced the Boolean data type with you. In the next video, we will see where the Boolean data type actually appears and how it impacts our our programming style or thinking style or coding style. So hope to see you in the next video with comparison operators that actually produces the Boolean variables. Hope to see you in the next video. Okay, in the last video I discussed Boolean data type, and I discussed that a Boolean variable takes either a true or a false, and we can combine these Boolean variables together with and or operators, and then we can apply a not operator on a particular variable, and we saw that a true and true returns true, and otherwise returns false. Similarly, a false or false is false, otherwise or always returns a true. Before actually discussing these comparison operators, let's just go to Jupyter and just play with a Boolean data type just for a moment. Let us just convert this to markdown cell and just write bool. That's a Boolean variable. So let's say A is true and B is true and C is false, and okay, so these are our variables. Let's press whos to see what are the states of. So A is a Boolean variable with value true, B is a Boolean variable with value true, C is a Boolean variable with value false. So now A is true, B is true, C is false. So let me print A and B. What do you think? What will be the result? Let me print A and C. What will be the result? And let me print C and A. So because A and B both are true, the first result will be true. Because C is false, true and true is true, the other two statements, they will result false. So first value will be true, then false, false. So yes, true, false, false. Let's check the OR. Print, and by the way, let's store that OR in another variable. Let's say A is true or C is false. So what do you think? What will be the result here? Because OR gives false when both are false. Here A is true, so the value of D will be true. Further, not A, because A is true, not A will be false. Similarly, not B, B is true, so not B will be false. Not C, C is true, C is false, so not C will be true. Similarly, not D, we can save the result in another variable, let's say T, and we can just check the type of T if we want. That's a Boolean. We can also check the value inside T, and that is false. Yes, not only that, I mean, we can combine at a higher level. For example, A and B, whatever the result is, or C or D, whatever the result is, and whatever the result is, not of that. I mean, we can combine them in a very complicated way if we want. A and B, the result will be some Boolean. That Boolean and that Boolean, there are. The result eventually will be a Boolean, and then not of that. So let's check what that is. The result is false. Well, why the result is false? Figure it out why the result is false. Let me go to comparison operators. So the comparison operators, let me just go to comparison operators. This equal to, it compares whether two variables, whatever the variables are, whether they are integer, floating point, whatever, whether two variables they have same data or not. For example, x equals to y, that will be true if x and y, they both have same data. So for example, if x has value 4 and y has value 4, then we are just checking x equal to y or not. The result will be Boolean, because and x may not be a Boolean variable, y may not be a Boolean variable. If we want to compare the values of x and y, then we write double equal without a space inside. Remember, if we write single equal, that will be an assignment operator. If we write double equal, that means we are checking whether the two values are same or not. Similarly, if we write this particular symbol, that checks whether two values are not equal or not. For example, x is not equal to y. The result will be true if x and y, they both have different values. Otherwise, the result will be false. Remember, the result of comparison is always a Boolean. It is either true or false. Okay, next we check whether less than. So for example, if x is less than y, the result will be true if x indeed has a value that is smaller than y. Let's say x is 2 and y is 10. In that case, the result will be a true. Otherwise, the result will be false. Similarly, we can compare the two variables using greater than. We can compare the two variables by less or whether one variable less or equal to the other. For example, if x is less or equal to y, the result will be true of this comparison. The result will be true if x has a value that is not larger than y. As long as x and y, they are equal, or x is smaller than y, in any case, the result will be true, otherwise false. Similarly, greater than or equal to. Okay, so I end this video here. In the next video, we will be moving to Jupyter and playing with these operators and seeing the return types of Booleans, and then combining them together with ands and ors and doing interesting stuff with that. In this particular video, I just talk about the comparison operators, the Boolean data type, and combining them by and, or not. In the next video, we'll be first moving to Jupyter. We will see the comparison operators. We will write all these statements in Jupyter and just get a good hands-on grip on that. And then we'll be moving onwards. So hope to see you in the next video. So in the last video, I talked about comparisons, double equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. So let's go to Jupyter Notebook and see how they actually work. So let me just first enter a markdown cell and type that comparisons. Shift enter comparisons. So we can compare different values by first assigning them to variables and then comparing those variables, or we can compare the values directly. For example, print 2 is less than 3. What do you think? 2 is less than 3. The result will be what? Remember, the result of a comparison operator is always Boolean. It is either true or false. So in this case, 2 is smaller than 3. So the result will, because this statement is true, so the result will be true and true will be printed. Further, we can store that result in another variable. For example, 2 is smaller than 3. Whatever the result is, the result will be true. The result will be saved in a variable C. If we check the type of C, as long as let's print the value of C, so you can see the type of C is Boolean, and C in this particular case is true. Moreover, for example, let's have 3 equals to 4. Is that true or false? What do you think? 3 equals to 4. 3 double equals to 4. That is false. 3 is not equal to 4. And let's save this result in D. Remember, 3 double equals to 4. That's an operation. The result is false. This equal is an assignment operator that the false value will be assigned to the variable D. And here we can see print D when it is false. Similarly, what do you think? 3 double equal to 3.0. What will be the result? Remember, 3 is integer. 3.0 is a floating point number. And I'm comparing 3 double equals to 3.0. One is integer, another is a floating point number. So what will be the result? Let's see. The result is true because they are comparing the values by discarding the decimal position. Further, let's see. 3 is smaller or equal to, so let's say x is equal to 4, y is equal to 9, and z is equal to, let's say, 8.3, and r is equal to -3, let's say. And these are our variables, let's say. So what do you think? What will be the result here? X is smaller than y. What will be the result of that? X is smaller than y. The result will be true. And z is smaller than y. The result is again true because z is smaller than y. Or r is equal to, for example, x. So what do you think? What will be the result at the end after this? So let's see first this will be true. This will be again true, and that is false. Okay, so this true and true will return true, and true or anything, the result, final result is true. So this will return true. But if I just switch the order, for example, if I just write this statement, which is false, this particular statement here, and then I do this, what will be the result now? Now see, x is smaller than y, it is true. R is equal to x, that is false. So this result will be false eventually. And z is smaller than y, that result is z is smaller than y. Let me just say z is larger than y. Let me just check z is larger than y. Z is larger than y, just to tell you. So this is true, this is false. Both and of these, or let me switch this thing. R equals to x. I just want to show you the precedence of r and x is smaller than y. So now if you see, this is false, this is true, false and true is true, true or false and true is false, this is also false, and the result overall is false. It should happen. But what if this goes first? If this goes first, I mean, I want to show you whether and or, which one of them will operate first. So in this particular case, the result is false, but it can happen. Let me tell you this in more and true or false and true or false and true. What do you think? What will be the result here? True or false and true. If true or false operate first, if true or false operate first, the result will be true. True and true, the result is true. If, however, let me just write a false here. If or operates first, then false or false is false, and false and true is, the result eventually is false. And if and operates first, then false and true is false, false or false. The result in both cases here is false. So a better way of representing these kind of, sometimes they can make confusions. Sometimes they can make confusions. For example, if you have a true here, if you have a false here, for example, false and true, how can I, so false, false and false or true. So in this case, if false or true, that operates first, the result will be true, and false and false, false and true, the result will eventually be false. However, if and operates first, the result will be false here, false or true, the result will be true. So here, if and applies, if and is applied first, then the result, overall result will be true. But if or is applied first, then the overall result will be false. So it is good to know whether and will be applied first or will be applied first. In this particular case, and will be applied first, even if you change this, even if you change this order. For example, even if you pick this thing and you apply here, still the result is and will be applied first and or will be applied after. It is always good, rather than to, one way is to remember the precedence and will be applied first, then or. I mean, it is good to think about the precedence. Another good thing is to specify the order using parentheses. For example, now we specify this first or will be applied and then for